My name is Sanusi I'm a student of Nazarbayev University from Kazakhstan. I'm a second year master student. I'm here to present my paper to the ICPA conference going to take place in Malaysia. Let me just share my screen. The title of my paper is a perovskite MPPT design for PIPV application. And presentation outline with introduction, proposed design circuit, design analysis, result analysis, and conclusion. And as we know, to prevent environmental harms, the usage of the renewable energy has increased globally, and then the global demand for clean energy made renewable energy an attractive research field. Given the abundance of the sunshine, solar energy is anticipated to be the foundation of sustainable energy economy. A perovskite PV is a type of solar cell that uses a perovskite structural material at light absorbing layer, and also perovskite PV cell as having a high lighting to electricity conversion efficiency, which can be result in high energy yield compared to the traditional silicon-based PV cell. And perovskite PV cell can be produced at lower cost and with a simpler manufacturing processing compared to the traditional PV cell. And we also perovskite solar cell can be also be made in a flexible form, which can be enabled integration into the various building materials, such as glasses, metal, plastic, providing more option for the building integrated photovoltaic system. And PIPV is an integration of solar cell into the building envelope, such as roof, wall, and window. As you can see in figure 2 here, was able to demonstrate how solar cell was able to use as a window for building, as in top of the roof and on top of the maybe like garage. And importance of MPPT for PIPV system. One of the there are many importance of the MPPT for PIPV system, and MPPT is crucial for the PIPV system because it allows the system to operate at the most efficiency point, minimizing the power output and minimizing energy loss. And also, MPPT also allows the system to adapt to changing weather conditions, ensuring the optimal performance throughout the day. And also, PPT can also protect the PV cell from damaging by preventing the over current and over voltage condition. And also, and then the design proposal design of the circuit, we have a figure 3 show piano operation, and we also have the flow chart here, which is shown in the figure 4. And you can see it here now. We also this is circuit in figure 5. This is circuit design for the piano MPPT. As you can see, we have multiplier circuit, we have sample and node circuit, we have three-stage comparator, we have decision circuit, we have compensator which is used to stabilize the circuit, and we have ramp signal generator, and we also have comparator which compare the signal between the compensator and the ramp signal, and then we have a PMW signal which is going to power the MOSFET. And this figure 6 was systematic of the proposal energy efficiency system and P&O MPPT circuit. As you can see here now, we have PC module which is connected to the circuit, and also we have, like I said before, we have multiplier circuit which is used to multiply the output voltage from the PV module and from the PIC module, and from and then to able to multiply to send the current, to multiply the current sensor. And also here the signal from the voltage signal and the current signal was able to multiply here and then transfer to the three-stage comparator, and yet to also transfer to the sample nano, which also transfer to the comparator in order to compare the signal between the multiplier circuit, and then the sampling and node circuit, which is transferred to the decision circuit, in order to be able to achieve MPPT, P&O MPPT circuit. And then we have a compensator circuit. So compensator circuit, the purpose of compensator circuit was to stabilize the circuit, and then they receive the signal from the decision circuit, and then we have a ramp signal generator, and then here we have a comparator which compare the signal from the comparator and then the ramp signal in order to send to the in order to send to the PMW signal to power the power MOSFET in order to achieve our output voltage. And then and as you can see here now in table 1, show the value of PVC cell when it's connected in series and parallel. The purpose of connecting in series and parallel was to increase the voltage and then increase the current, and then it was used to as a power source, and the table also the DC-DC boost converter circuit parameter. As you can see here now, when it's connected under the sun without connecting to the circuit, the power was 127 milliwatt, and when it's connected under the artificial light, the power is 160.8, and when it's under the sun, also the open circuit voltage is 2.4, and open circuit voltage when it's under the light is 2.2, and also short circuit current when it's under the sun is 78 and 74.92, and when it is under the artificial light was 70 milliamps. And this is inductor that used as a parameter to calculate our DC-DC boost converter is 470 microamps, and the output capacitor was 820 picofarad, and the switching frequency was 5 megahertz. And as you can see here, this is my short here. When the perovskite was under the sun and connected to the circuit, I'm achieving the input power. My input power was 11.47, and my output power is 1.11.02. That giving us that my P&O method MPT was working properly, because I'm able to achieve to extract the power from perovskite solar cell minimum or in maximum of 98 to 98%. As you can see here, then my input power and my output power was able to have the same value, and I was able to achieve my output voltage, which is 5.1. And also when it is under the light condition, I'm also to achieve my output power, which is also output voltage, which is also 5.1 volts, and also my input power and my output was able to distinguish. I was able to extract the power by using P&O MPPT method. The purpose of this is that I'm aiming to design a circuit that is going to have the same output voltage when its perovskite solar set is under the sun and when it's under the artificial light. And I was able to achieve that because my output voltage was able to 5.1 volts, and when it's under the sun, and 5.1 volts, and when it is under the artificial light. As you can see it here now, this is my value that I generated when it connected under the light condition. And in conclusion, and this study used MPPT based on modifying the pin anode to extract the most power possible from PSC module, and the MPPT control circuit architecture and the high efficiency DC-DC boost converter make up the hardware. And the PSC module is connected in series and parallel to determine the open circuit voltage and short circuit current. And the two condition instances are investigated to ensure that the proposal system has the same output voltage for PIPV application. This demonstrates that under the two situations, the P&O algorithm offer an effective and trustworthy maximum power tracking performance. And then the purpose of energy, the proposed energy harvesting system is realizing using cadence in the UMC 180 nanometer technology. Thank you everyone for listening. Thank you very much. Bye bye.